Right, and now we're going to answer some questions about the lesson from 9.4. Okay, so Sydney, why don't you go ahead and give me
29 negative 10n squared plus 35n equals 0. How to figure that out?
And we want to find out what values can I put in for n that's going to make that equal to 0. Right? Well, the first thing I'm going to ask you now is we're going to factor that. And can you tell me what these two, you have two terms here. You have negative 10n squared and you have 35n. Can you tell me what do they have in common?
5.
They have a 5 in common. So I'm going to take that out. And you know what? Because I'm starting off with a negative, let's make this a negative 5. Okay? And what else do they have in common? N. So we're going to take that out as well. Now, negative 5n times what will give me negative 10n squared?
2.
2n. I need another n, don't I? Yeah. And then I'm going to need a minus here, not a plus, because a negative times a negative will give me the positive. 7. And that's it, isn't it?
Yeah.
Okay. And that equals 0.
Yeah, I just have one more.
Well, let's finish this one up, okay?
Oh, it's not finished?
No, because we have to find out what is n equal to. We factored it, okay?
Oh.
Well, now, negative 5n could equal 0. Remember that one thing we said the other day, that we have this product property that says if AB is equal to 0, then one of them has to equal 0, one or both. So either negative 5n has to equal 0, or 2n minus 7 has to equal 0. And we want to solve these equations. So for the first one, we're going to divide by negative 5, both sides. And what is 0 divided by negative 5? 0. That's one solution. For the other one, I'm going to add 7. We know how to solve these equations. I'm going to add 7 to both sides. The result is going to be 2n equals 7. And then we divide by 2. And you don't really have to get fancy here. I don't think we need a calculator here. Because you can leave your answer as 7 over 2. You don't have to make it 3.5 or 3.5. You can just leave it as 7 over 2. Okay? Question? Do you have a question on this one? Okay. Because I just want to make sure that everybody understands. Do you understand this one? Okay. All right. All right. Now make sure I answer everybody's questions on this. All right. So you said you had another one. Let's say here.
Yeah, plus 7.
Yep.
B squared plus 6b equals 0.
Now, some people say that my 6's and my b's look alike. B's I write in cursive, and then you can see the difference when you write 6b together. But okay, what do those two? And I'm gonna ask Sydney the same thing that I asked the first time. So Sydney, what two? You have two terms up here, and what do they both have in common? They both have a b in common, so we're going to factor that out. And I'm left with b plus 6. Because b times b is b squared, and b times 6 is 6b, correct? Now I'm going to look at this, it's called the zero product property. I'm going to look at that, and one of these has to equal 0. Either b has to equal 0, that's one solution, or b plus 6 has to equal 0. I subtract 6 from each side, and b equals negative 6. That's your two solutions. Does that make sense, Sid?
Yeah.
Good. Okay, Jessica? What was your question? I did? Okay, good.
But wouldn't negative 6 have to be divided by b?
No, because I want to know what b is equal to in the original problem.
Oh, okay.
Yeah, so b could equal negative 6. If I were to insert negative 6 in place of b, I would get 0.
Oh, okay.
And if I would insert 0 for b, I would also get 0.
Okay, 'cause-
Just like, yeah, and just like in the first problem, if I put in 0 for n, I will get 0 in the original problem.
okay. So,
Or if I were to put in 7 over 2.
so really we only had to divide 7 by 2 because it was in front of that.
Correct.
I have a question.
Yes.
Why, like, I understand how you did, you factored it, they both have b in common, then you have the parentheses, b again, because you have b squared,
Yes.
right? So then you did plus 6, but what about that b?
Okay, because if I distribute, good question. If I distribute, b times b is b squared, correct?
Uh-huh.
And you have to distribute, and then b times 6 is 6b.
So you already have the b.
You already have it there, all right? Okay. Kristen, what's your question?
Okay, so for number, wait, there was one where it was like 3 and 16, so 3b plus 3 plus 3x.
Go ahead, 3x.
3x to the 4th.
Oh, 3s to the 4th? All right. 3s to the 4th
Plus 16.
plus 16s. Oh, okay.
And then like so.
And what do the directions say, though? See, this doesn't equal, you're telling me this does not equal 0, or does it? I don't know. This is problem number 19? Does, what,
Directions say factor out the greatest common monomial.
okay. So really, this does not equal 0. They're not asking you to solve this. Question.
Oh, I was
Okay. So what they want you to do, Kristen, what do these two terms have in common? S. I don't think there's anything else that they have in common. S is the only thing they have in common. So we're going to factor that out.
My question was though, like, in situations like this, could we use like 2 and have like decimals in it? Or
No. Oh, good question. You know what you said? Can you use a 2 here and then have decimals, like 2 times 1.5 will give you 3, and 2 times 8 will give you 16? No. We don't want to use any decimals. But there's nothing that goes into 3 and 16, so we're just going to leave those.
Well, if you were to divide by 2.
Yeah, but no, I don't want you to. That's what I just said. If you divide by 2, you're going to get 1.5. I don't want you to put, 2 times 1.5 to give you 3. No fractions, no decimals.
So you just leave it?
Oh, I'm not done yet. So we want to take out the greatest common factor, which was s, correct? S times what gives you 3s to the 4th? 3s to the 3rd. Plus what? Plus 16. And you're done. So there you're looking for the greatest common factor. Don't get caught up in the vocabulary, because I think it said take out the greatest common monomial. Well, if it's one term, that's a monomial. All right. We took out the greatest common monomial in the second problem by taking out a b. We took out the greatest common monomial here in the first problem by taking out a negative 5n. That's taking out the greatest common monomial. Okay? Are there any other questions on?
Can you just do 33 or
Sure.
I'm second?
Problem number 33. Could you read it for me?
3k squared minus 6k.
equals.
Minus 6 equals 6k?
Yeah. Sorry.
And what do they ask you to do? Solve it for k?
Yeah.
All right. if you look at the first two examples I gave you, don't they equal 0?
Yeah.
That one doesn't equal 0. Do you have a question or an answer? All right, Emily, go ahead. What do you think we would do to make it equal to 0? Subtract the 6k from each side. Because 6k minus 6k is 0, and I'll subtract from this side. Those two terms, yes.
You don't have to be on the right side.
You know what? It does not have to.
So you could just try to split it.
If you did, I think this will be a little bit easier, and I'll tell you why in just a second. When you have 3k squared minus 6k, I have to write it as 3k squared minus 6k. Because those two terms are not alike. I can't combine them at all. All right? And I think it's easier, Luke, when this is in standard form. Sorry, I did it again. Zach, I think it's easier when when this is in standard form and you have the highest exponent first, if that first term is a positive. Okay? I get that stuck in my head and I can't. All right. So what do those two terms have in common?
2. Oh wait, just kidding.
3 and
3 and
don't they both have a k?
yeah, K. Sorry.
All right. So let's take a 3 out and a k out. All right. And so in the parenthesis, I'm going to have k minus 2. Okay, everybody follow so far? So either 3k has to equal 0, or k minus 2 has to equal 0. Divide by 3, and k could equal 0. On this one, we add 2, and k could equal 2. So we have two answers there. Okay. Do we have any questions for me? And basically, this was your lesson on 9.4. All right, so let's go over what your quiz is going to be. It's going to be over sections 9.1 to 9.4. In section 9.1, we dealt with monomials, binomials. We added them together, subtracted them. All right. Basically, what we're doing is we're combining like terms, aren't we?
Yeah.
Okay. All right, so that's what we did in the first section. We had some vocabulary too. Polynomials, we had monomials, binomials, trinomials, and those are all polynomials. In section 9.2, we were multiplying polynomials together. We learned the FOIL method. We learned distributive. Okay. And we didn't seem to have too many problems, too much difficulty with 9.2. 9.3, we were multiplying binomials together. And they were called special products. And that's where we had that three-step process, which we could have used FOIL, correct? But we had where we could square the first term. You remember that? 9.3. If we had a problem like x plus 4 squared. Okay, we had that three-step process. You can look at your notes where the first step is square the first term. Second one, well, let's square the first term. x squared. Right? That's step number 1. Step number 2. Multiply the terms together and do what? And double it. So I'm going to multiply x times 4 to get 4x and then double it. So this would be step number 2. So then you're going to have 8x is correct. Step number 3. Square the last term. So we want to take number 4 and square it
16.
to get 16. And this is step 3. All right, so we have step 1, square the first term. Step 2, multiply those two together and double it. Step 3, square the last term. I also want to tell you guys that it's the same answer as if you do this. If you have x plus 4 squared, you can put them side by side, because that's what, when you square a term, that's what it means. And then you can use FOIL. X times x is x squared. X times 4 is 4x. 4 times x is 4x. Do you see where we're taking 4x and doubling it? And then 4 times 4 is 16. You're going to add these two terms together. And of course you're going to get the same answer. But if you know that 3-step process, it really makes your work go a lot quicker. Okay? And that was in section number 3. We also had something called the difference of 2 squares. We had something like this. X minus 5 times x plus 5. Can anybody tell me what a quick answer would be? Yeah. No? What do you think?
X squared minus 25.
That is the answer to this problem. X squared minus 25. This is why. How come we didn't have 3 terms here? Do you remember, Emily?
Because you have 2 different signs.
You have 2 different signs there, right? And they'll cancel each other out. Watch when you use FOIL. X times x is x squared. X times positive 5 gives you a positive 5x. Negative 5 times x gives you a negative 5x. And negative 5 times a positive 5 is a negative 25. And if you look at those 2 middle terms, 5x minus 5x cancel each other out. It adds up to 0. And we're left with x squared minus 25. If you can recognize that, both these are the same except the signs are different, you can go from here right to the answer by multiplying the first 2 together and the last 2 together. And you get x squared minus 25. The difference, subtraction, of 2 perfect squares, x squared and 25. Okay? Now this last section, we were factoring out a common factor, and we were also solving for 0. All right. I'm going to put all this information on 9.4 link. So if you guys wanted to watch that tonight to get another review of what's going to be on your quiz tomorrow, it's going to be over the first 4 sections. Does anybody have any other questions for me? It'll be a fairly short quiz, and what I think I'm going to do then tomorrow, we're going to try. It depends how long it takes you to do the quiz. What I'd like to do is, I'm going to give the lecture for Monday, because I think it's going to be easier for me to talk in front of a live audience than it is if nobody's in the room. All right, you can take notes if you want to, but we'll show the video on Monday. And I'm not going to be here on Monday. So we're going to show the video on Monday. And then I'll put the assignment on the board. Okay? So you'll be able to do the work.
So we won't have homework tomorrow?
That is correct. Is that all right? I don't want to shortchange you.
Is tomorrow Friday?
Yeah.
Tomorrow is Friday.